So in this example, ladies and gentlemen, as I have kind of mentioned, or at least the 3 problems, we're going to do 3 problems. The warm-up was just to kind of get you guys used to what we're going to be doing and basically offer there. But now we're going to kind of go into just 3 examples. And then, like I said, I'll have stuff for you guys to do at the end to give you guys some time to try them. So basically what we're going to be looking at in this case is, first thing, is determining the LCM. Now, it might be obvious to you guys to say, oh, well, let's just do x minus 2, or let's put LCM up here. It might be saying, well, the LCM is x squared minus 4 and x minus 2, right? I mean, that's what we did before. We just multiply them. However, I will say when simplifying, when adding or subtracting, just like we did multiplying and dividing, the first thing we should always do for all of the problems is always simplify. Okay, so it's really not like the first step just in adding, subtracting. It's anytime you're doing rational expressions, you always need to simplify. So I can't factor any of these by simplifying, but I do see that x squared minus 4, that's a difference of 2 squares. If you guys remember difference of 2 squares, a squared minus b squared can be factored into a minus b, a plus b. So therefore, if I factor this, I get 4x plus 1 divided by x minus 2 times x plus 2 minus 3 over x minus 2. So the reason why that's so helpful is because now, do you guys see, do they actually share an expression? Yeah. Yeah, they share the expression x minus 2. So the LCM is x minus 2 times x plus 2. But what's nice about that is, look at this already has the LCM. So I don't have to do anything with that.
So you have to multiply by x plus 2.
So I just need to multiply this by x plus 2. Where are you confused at? Squaring?
Yeah, why did you break it down?
Because I factored it.
So you always have x plus and x minus?
Huh?
Does one always have to be x plus and x minus? Or do you do that?
For the difference of 2 squares. If you have an equation, a squared minus b squared, where you have a squared term minus another squared term, then that gets factored into a minus b times a plus b. That is the difference of 2 squares factoring technique. So now we go ahead and multiply, and I have 4 plus x divided by x minus 2 times x plus 2. Over here, I'm going to distribute this as a negative 3. So that's going to give me a negative 3x minus 6 times x minus 2 times x plus 2. Actually, you know what? Let's not do that. Sorry. Yes?
It's supposed to be 4x plus 1, 4 plus x.
Oh, thank you. 4x plus 1. And let's just keep this like this, actually, for a second. X plus 2. So now what I'm going to do is let's go and distribute. If I distributed it, that would become 3x. Actually, that's fine. Right. So actually, let's just let me just make sure I don't want to overly confuse you. This is a negative 3, so let's distribute the negative 3. Okay. So if we distribute this a negative 3, I'm going to finally get altogether a 4x plus 1 minus 3x minus 6 all over my common denominator of x minus 2 and x plus 2.
But
now,
you just made it into a huge problem.
well, what I did, remember, you can combine them. Right?
I didn't know that.
No, yes, you did. 1 plus 4 plus 3 plus 4 is the same thing as 1 plus 3 over 4. Right? When you have common denominators, you just add the numerators. Right? So what? Here, watch. I'll break it up into one more step. I have 4x plus 1 over. Now remember, when you change this to a multiplication problem, you're basically making these now addition, x minus 2 over x plus 2 plus negative 3x minus 2. I distributed the negative, so I turned it into an addition problem. Do you guys remember? Yeah. Distributing negative makes it addition. So therefore, now it becomes x minus 2 times x plus 2. So I'm breaking it up into one extra step. Now do you see that you're just going to add these? Well, you can only add like terms. 4x and negative 3x, and 1 and negative 1. So the final answer is going to be x minus 1 over our common factor of x minus 2 times x plus 2, where x cannot equal negative 2 and or plus or minus 2.
Wait,
But you distributed it 3, so 6.
Oh, yes. Thank you. Did I write that? Thank you. 6. So that should be -5, right?
So you distributed the negative and the 3. So that's why that's
Yes.